Hello there, welcome to Pre-Cal Lecture 1.4 where we're going to go through an exponent review. Before I get started, if this video helps you out, please consider buying me a coffee. There will be a link in the description box, or you can scan this QR code. It's just a $3 donation to help me continue to make these videos. Alright, so all you're going to need is pencil and a piece of paper. So we'll go with section 1.4.1. We'll call this exponent definition. I'm not really going to write out a definition here, but let's say that we have x times x times x times x times x. So we could write it out that way, multiplying 5x, but that's really not a very efficient way to write it, is it? A better way to write that is x to the fifth. That means the same thing if you multiply x by itself 5 times. We call that x to the fifth. Let's say we have 5 times x times x times x minus 2 times x equals 0. What would be a more efficient way to write that? Well, how about 5x cubed minus 2x squared equals 0? Okay, so that's a better way to write it. So section 1.4.2 we'll call evaluating exponential expressions. So if we have a negative out front, 3 squared, that is not the same, it's not equal to negative 3 inside the parentheses squared. This is the same as multiplying a negative 1 times 3 squared. And this is the same as multiplying negative 3 times negative 3. Okay, so this would be negative 9, 3 squared is 9, and this would be positive 9. Negative 3 times negative 3, positive 9. So you have to be careful with your parentheses, okay? So a lot of times this would be considered 9, but it's not 9. It's only if that negative sign is within the parentheses. So you must consider whether or not the negative sign is inside the parentheses. Okay, so exponentiation always occurs before multiplication. So that's part of your order of operations. You always do exponentiation first. So something to keep in mind. All right, let's start with a bunch of example problems. So our first example problem is, let's take negative 3, all in parentheses, squared, times negative 2 squared. Okay, negative 3 times negative 3 is 9. And then 2 squared is 4, but but that would be, that negative is not within parentheses, so it would be 9 times negative 4, and that's negative 36. All right, how about 7 minus 4 minus 2, all cubed, plus negative 2, all cubed. So we're going to work inside out. That's 7 minus 4 minus 2 would be 2 cubed. And then negative 2 times negative 2 times negative 2. You could try that in your calculator if you're confused, but that's going to be negative 8. So that would be minus 8. So that's 7. 2 cubed is 8. Minus 8. Minus 8. That would be negative 9. All right. We're still within 1.4.2. Got more example problems to go. So the next one is, all of these you want to evaluate. That's my the instruction is to evaluate. So negative 4 and then a bracket. We have 2 times 4 squared minus 5 squared, all squared. So we'll do the negative 4 last. Let's work within the bracket. 4 squared is 16, so that's 2 times 16. 5 squared is 25, so minus 25, all squared. That's going to be negative 4 times 32 minus 25, all squared. That'd be negative 4 times 7 squared, which is negative 4 times 7 squared is 49. So that would be negative 196. So that's the process you need to do. Work inside out. Exponentiate first, then we multiply, then we're going to subtract, and then once we get it down to a single number, we'll exponentiate what's in the brackets. Okay. So let's go to next section, 1.4.3. We'll call this applying exponent rules. So let's say we have 2 to the third times 2 to the fifth. That does not equal 2 to the 15th. Okay, you don't, if you have this, a base raised to a power, and you multiply, you don't multiply the powers. Okay, so that's not true. This is the same as 2 times 2 times 2. And this is the same as 2 times 2 times 2 times 2 times 2. So you have 8 2's multiplied together. So you have 2 to the 8th. So 2 to the third times 2 to the fifth is 2 to the 8th. So our rule that you need to memorize would be a to the n times a to the m is equal to a to the n plus m. So if it's the same base raised to a power, when you multiply, you would add the exponents. Let's say we have division, a to the n divided by a to the m. So that's equal to a to the n minus m. So for example, if we have 2 to the fifth divided by 2 to the third, that's going to be 2 to the 5 minus 3 That's 2 squared, which is 4. Okay, so a lot of students will get this mixed up and end up accidentally multiplying the exponents when they need to add. So I'm going to do a lot of practice problems to try to help you avoid getting that rule wrong. Okay, let's try. So we're still within 1.4.3. Let's say we have 3 to the 4th times 5 to the 4th. So different bases. That does not equal 15 to the 8th. You don't multiply the bases and then add the exponents. So that's not equal. This is the same as 3 times 3 times 3 times 3 times 5 times 5 times 5 times 5. So you have 4 3 times 5s. Multiply it together. So that would be 15 to the 4th. So if you have different bases, raised to the same power, you would have a couple of rules here. A to the n times b to the n is equal to a times b to the n. And also a to the n divided by b to the n is just a over b, whatever that fraction is, raised to the n power. So let's have an example here. Well, let me give you one more rule. Let's say we have an exponent raised to another exponent. So this is what students get confused. When do I add and when do I multiply? This is when you multiply. When you're raising an exponent to another exponent, it's a to the n times m. Okay, so you add when you have the same base raised to two different powers, and you multiply, then you add. When you have an exponent raised to another exponent, that's when you multiply. Okay, let's do a bunch of exercises as examples. So we would evaluate 2x cubed y to the 4th times 3x y to the 5th all squared. So I'm gonna evaluate this parenthesis first because all of this is just raised to the first power. So I'm just going to rewrite that. 2x cubed y to the 4th. Okay, then we're going to raise each one of these components to the second power. So that would be 3 squared, x squared, so times x squared, and y to the 5th squared we would multiply, right? 5 times 2, that'd be y to the 10th. All right, so that's going to be 2 times x cubed. Now I'm going to put the x's together, times x squared, right? X cubed, x squared, times y to the 4th, y to the 10th. I'm just putting them together. You don't have to do this. I'm doing this for illustrative purposes. And then 3 squared is 9. So to finish this up, that would be 9 times 2 is 18. X cubed times x squared. This is where you add. That'd be x to the 5th y to the 4 plus 10 14th. Okay, so probably most of you would go ahead and do all that in your head and skip straight down to this, but I just wanted to be a little more illustrative there. All right, so a bunch more examples for this section, and then hopefully you'll have it down if you don't already. So we want to evaluate x to the 5th times y to the 7th times negative 5x squared y squared all raised to the 4th power. Now x to the 5th times y to the 7th is just really to the 1st power, so I'm just going to rewrite that again. Okay, so each one of these components I'm going to raise to the 4th power. So we would have negative 5 to the 4th times x squared to the 4th. We're going to multiply 2 times 4, that'd be 8. Raising a power to a power, so don't add, it would be multiply. And then y squared to the 4th would be y to the 8th. Now if you're not sure what 5 to the 4th is, so it's negative 5 times, let's put that in our calculator. So then put parentheses around it. So in fact, that negative out front, when I raise it to the 4th, that's the same as negative 5 times negative 5 times negative 5 times negative 5. Okay, so that's why I put the parentheses around it. It's going to, 4 negative times a negative times a negative times a negative would give you a positive. So negative 5 raised to the 4th power is 625. This is 625. So what we would have here is 625 times x to the 5th times x to the 8th. So I'm putting the x's together, times y to the 7th times y to the 8th. So that would be 625 times x to the 13th times y to the 15th. 7 plus 8, 15. All right. Next one, let's say we have x squared over 2 all raised to the 4th power. Well, that's the same as x squared to the 4th over 2 to the 4th. That would be 2 times 4 is 8, x to the 8th, don't add, all right, when you're raising an exponent to an exponent, you got to multiply 2 to the 4th, 2 times 2 times 2 times 2 is 16. So that's really as far as we can go with that one. All right, let's say we have 4 over n to the 6th all squared. That's going to be 4 squared over n to the 6th all squared. 4 squared is 16. N to the 6th squared would be 6 times 2, be n to the 12th. All right, this next one need a little more space, so I'm going to go ahead and erase. So we're still in 1.4.3, just giving you a lot of examples. So let's say we have 3x squared y to the 4th raised to the 5th power over 3x cubed y to the 7th raised to the 3rd power. So let's raise each component to the 5th power. So that would be 3 to the 5th. X squared to the 5th would be x to the 10th. 2 times 5 is 10. And y to the 4th to the 5th would be y to the 20th. And then on bottom we would have 3 to the 3rd, x cubed to the 3rd. 3 times 3 would be x to the 9th. And then y to the 7th to the 3rd would be y to the 21st. Now to simplify this down, I want all positive exponents. So only positive exponents. So what you have here is you just, whichever one wins. So if the top is greater than the bottom, then what you have left will be on top. So this is the same as 3 to the 5 minus 3 times x to the 10 minus 9 times y to the 20 minus 21. But what I want to do, so you can cancel this out. 5 minus 3 is 2. You can cancel the x to the 9 out. 10 minus 9 is just 1. But since y to the 21st is bigger than y to the 20th, I want to leave what's left, 21 minus 20, I want to leave that on the bottom. So what you have left is 3 squared on top, x to the first power on top, and then y to the first power on bottom. So that's just 9x over y. I hope that made sense. You know, since so whoever wins, whatever exponent wins, they stay on top or bottom. Okay, so this time with the y's, the bottom one, so we leave it 1. When I say 1, I mean W-O-N, it 1. So you leave it on bottom. Okay, last example I think would be 5xy squared to the 4th over 5x squared y to the 6th. So that's 5 to the 4th times x to the 4th, x to the 4th, y squared to the 4th would be y to the 8th over 5 to the 6th. X squared to the 6th would be x to the 12th, and then y to the 6th. Okay, so we're only going to have on top a y, because for the 5 and the x, they both had larger exponents than the 5 and the x on top. The ones on bottom had larger than on top. So what's left, you have y to the 8th over y to the 6th. That'd be 8 minus 6. You have left on top is y squared. 5 to the 6th, 5 to the 4th, that leaves you 2 on bottom. 6 minus 4 is 2. And then x to the 12th, x to the 4th, that leaves you 12 minus 4, x to the 8th on bottom. So that's going to be y squared over 25x to the 8th. That's the way to keep them all positive. Okay, let's go to the last section for this lecture. All right, so that's 1.4.4, which is evaluating expressions with negative exponents. Okay, you've probably heard in the past in prior math classes that anything to the 0 power is equal to 1. Well, why is that? Well, let's say we have 1 in terms of a would just be a over a, right? 1 is equal to a over a. It's the same thing. That's equal to a to the first power over a to the first power, which is a to the, when you have division, you subtract exponents, so 1 minus 1, which is a to the 0. So that's where that comes from, as long as a does not equal 0. So another reminder, if you have 1 over a to the m power, that's the same. You know, 1 is the same as a to the 0, right? Over a to the m, which would be a to the 0 minus m, which is a to the negative m power. All right, so that's how we can rewrite exponents as negative, like that. Okay, let's do some examples. So let's evaluate negative 3 to the negative 2 power. That's the same as 1 over negative 3 squared. We can move, we want to make that exponent positive. So if we do 1, this is the exact same thing. We can move that to the bottom, put a 1 on top, and these two are equivalent. That's negative 3 all squared. That's negative 3 times negative 3. That's 9. So that's the same as 1/9. How about negative 3 to the negative 3 power? That's the same as 1 over negative 3 cubed. Negative 3 times negative 3 times negative 3. You can put that in your calculator if you need to, but that's negative 27. So it's the same as negative 1 over 27. All right, let's say we have 3/4 to the negative 2 power. Now I'm going to show you a shortcut here in just a second. But first of all, let's do it the long way. So this would be the same as 1 over 3/4 squared. So I'm just moving all this to the bottom, make a 1 on top, and then I can make the exponent positive. That's the same as 1 over 3 squared is 9. 4 squared is 16. So 1 over 9 over 16. Well, when you have 1 over a fraction, you can just flip the fraction, and that's 16 over 9. Well, there's a little quicker way to do this. So I'm going to leave, let's see, I'm going to leave that bottom one on the board just for a second before I erase the whole thing here. You can rewrite this. You can flip the fraction 4/3. So take 3/4, flip it, and then you can change the sign of the exponent. So flip the fraction. And then you can change exponent's sign. Well, then that's just going to be 4 squared over 3 squared, which is 16 over 9. So a much faster way to think about it. Okay, let's work a few more examples, and then we'll be good with this exponent review lecture. All right. So let's simplify (8) a to the 6th b to the negative 4th over 24 a to the negative 8 b to the 9th. Okay, so what I'm going to do is rewrite this with, I'm going to move, I want all the exponents to be positive, so I'm going to move this a to the negative 8 up top and change the sign. So that would be 8 a to the 6th times a to the 8th, because I want my final answer to only have positive exponents. And then I'm going to move this b to the negative 4th to the bottom. So we have b to the 9 times b to the 4th. So I can move the b to the negative 4th to the bottom and change the sign. Now 8 over 24 is the same as 1/3. So I have a 3 on bottom. I don't have to write the 1. 6 plus 8, we would have a to the 14th. And then 9 plus 4 on the bottom, we'd have b to the 13th. Okay, so when you have the same base, the different powers, you add the exponents. And that's the way to get all of this into positive exponents, which is what we want. And we've simplified it. We've reduced the number of terms. All right, let's say we have 10 a squared b to the 6th over 50 a to the minus 3 b to the minus 4. Again, I want all exponents to be positive. 10 over 50 is the same as 1 over 5, right? So I can just have a 5 on bottom. I'm going to move that a to the negative 3 up top and make it a to the 3rd. And then I'm going to move that b to the negative 4th up top. So we'd have b to the 6th times b to the positive 4. All of that's over 5. So now we'll combine to a to the 5th, 2 plus 3 is 5, times b to the 10th, all over 5. Okay, just one more. Let's say we have 7 squared x to the minus 4 y cubed all to the negative 2 power over 7 x squared y to the 4th all to the negative 5 power. Now, I want to simplify this. You can go ahead and raise them to the powers through multiplication and then move back and forth. I think the easier thing to do is take this entire parenthesis, rewrite it. Now, what's in the parenthesis, you do not change the exponent sign. So I'm taking the bottom, rewriting it, but I'm making it to the positive 5. You don't change what's inside the parentheses, only what's outside the parentheses. And then on bottom, rewrite 7 squared x to the minus 4 y cubed, and then that's all to the positive 2 power. What that's going to do is give me a whole lot fewer negative terms to deal with. That's why I did that. So there will be a lot less movement in the end. Okay, you could go ahead and say this is 7 to the negative 4, x to the 8th, y to the negative 6, but there's going to be a lot more movement. Now you're going to only have this one negative term. So this would be 7 to the 5th, x squared to the 5th would be x to the 10th, y to the 20th, then 7 squared would be 7 to the 4th, x to the negative fourth squared would be x to the negative 8. And then y cubed squared would be y to the 6th. Okay, so 7 to the 5th over 7 to the 4th, that's 5 minus 4. That would just be 7. 7 to the 1st is left. 10 minus negative 8 would be x to the 18th power. Okay, that's 10 minus negative 8. We could move the x to the negative 8 up top and make it x to the 8th. It's a little faster, just 10 minus negative 8. That's 18. And then 20 minus 6 is 14, so y to the 14th. So that's a pretty big simplification. Now we're just down to 3 terms. When we started out, we had 6 terms. All right, that does it for this lecture. Your homework is worksheet 1.4. Now, in some years, I stop at 1.4.3, and I just give the first 12. If that's the case, for your teacher, just do that. But if your teacher gets through the entire lecture, or in this case, if I'm teaching it to you sometime in the future, entire lecture, then you would do all 16. But so for now, we're going to say it's the entire worksheet 1 through 16. And again, if this video helped you out, please consider supporting my channel by buying me a coffee. There's going to be a link in the description box, or you can scan this QR code. It's just a $3 donation. Thank you so much, and I will talk to you next video.